Alright, so let's look at our learning goal for today on the screen. Okay, today your goal is to calculate the standard deviation of a data set with 100% accuracy. So we cannot be, when we do our calculations today, we can't be off task because you're going to lose track of what we're doing and then you won't have that 100% accuracy, okay? So after each step we do, we need to all have the same numbers. Does that make sense? So follow along closely and you'll be fine, okay? But again, of course, the video is here in case you need to rewatch it later. Rewind, rewatch what we did, okay? All right. So yesterday we were looking at the delivery problem, and so if you were absent, you need to come get the golden sheet from up here. But what was our decision? Did we choose company A or B? B. B, why? More what? Consistency, okay? And what was our argument for company A? Why would we pick company A if we have to? They had more earlier times, right? But if we're trying to choose a company to do our food deliveries, we want someone that's consistent, not just all over the place, right? Now, the context of the data is varied, right? So, what was the word you learned yesterday? Variability, good. So, variability sometimes is good to have wide variability, but for this instance, we needed it to be less variability, okay? All right, so today we're going to look at a new calculation. It's called standard deviation, but this word we already learned, deviation. Turn to page 13, I believe. We wrote the definition down. Turn to page 13. And read it to yourself. What was the deviation definition? What is it? Deviation. Write it down. What problem were we doing when we did the deviation? The pencil, yeah, we were balancing the pencil with the ruler, right? So what is the deviation? Read it. The second one, yeah. Okay, so when we did the calculation on page 14, we did the left deviation and the right deviation, right? And fifth period, we were supposed to add them all up and equal to what? But y'all didn't do the calculations right. What was it supposed to equal to? Zero. Okay, so that is going to piggyback off of what we're doing today. But today we're doing the standard deviation. So what we're going to do is we're going to find the average deviation. Okay, so on your computer, I need you to make a dot plot for company A. Just really quick, make a dot plot. Everyone should know how to do that. What do we put in when it says early? Negative. Okay. Really quick, do a dot plot for company A. If you need help or if you forgot how to do the list on decimals, let me know. Yes, go on decimals. No. Press capital A equals. And then bracket. Yeah, the basic. Not the term. And then type your data. Well, this is hers. Oh. Okay, on my screen, I have this red line. Who remembers what that red line represents when we did our dot plots? The mean, good. So, what is the mean for company A? What's the mean? Who can tell us what the mean is? Remember, we have to be accurate. Can't just guess. 2.15. Good. How'd you get that? So everybody put on decimals because you need to know how to find it yourself. type mean, and then parentheses, and then A. So did you get 2.15? Yes. And then how do I get a vertical line on my dot plot? X equals, yes, X equals 2.15. Okay, type that. Oh, there's one. 2.2, then you type your data wrong. 2.15 is the mean. Okay? Alright, now this next part, everybody has their vertical line on Desmos, yes? Okay, the next question is, with your table, because I'm going to call on you, you're going to answer this question. Are the wait times typically close to the mean or typically far away from the mean? What does typically mean? Usually, okay? So, it's okay if you say they're usually close, or if it's okay if you say they're usually far. I just need to see your reasoning, which is the next question. How can you tell? Okay, so how can you tell if the data sets are close, or how can you tell if they're far? You can only pick one, okay? So with your table, you're going to write a sentence, and you're going to write it on page 16, where we were yesterday. So open your notebook, page 16, and write your answer as a table. Decide, is it typically close or typically far for company A? Okay, I'm going to put a timer. Okay, again, we're going to calculate the distance from the mean using Excel so that we can get that 0 in the deviations from the left side and the right side. Now, everybody go to my calendar on Canvas. There is a link with the data sheet, okay? But it's view only, so you have to make a copy and download it. That way you can edit on your tablet, okay? Again, it's linked on the calendar. Download it, and then you can edit on the document, okay? It's an Excel sheet on Excel. Is there a link? Did I not put the link? I did? Okay. Thank you. Okay, so the first column we're going to fill in is the wait time. And remember that when it says early, what do you type? Negative. All right, go. There should be 20 entries. Sorry. Remember, if it's early, you gotta put negative. Okay, when you type that all in, I put a formula here to give us the mean. Did you get 2.15? Yes, check on the bottom, under the data, on row 26. Yes, 2.15. If you don't get 2.15, which I didn't in the beginning, I messed up on a number. So use that as your check. Yes, we're good? Okay, now, the next part, we're going to be giving Excel formulas, so pay attention, okay? All right, I have the first column done, and I have the average. Can y'all see my formula right there? Okay, go to the next column. We're going to calculate the wait time minus the mean. What is that calculation? Why are we doing that? Okay. Yeah, to get an estimate of how close it is to that mean, right? The red line that you did on Desmos. So we're going to calculate the difference, the distance from that to the mean. So double click on that line. Double click. And to give Excel formulas, you have to start with the equal sign. Okay? And I want to calculate this wait time. So click the actual cell on -3. Click it. Y'all get the B5. And then minus what? What's the mean? 2.15. Okay? I'll pause so you can see. Equal sign, click this cell, A3, minus the mean, which is 2.15, yes? Can I click enter now? Alright, click enter, and there's the subtraction, okay? So to save time for us to not do each formula one by one, click on that cell again, and we're going to drag it. Drag the corner. Watch closely. See this little green dot? Everybody, drag it all the way down until to the last data number, number 3. Okay? How are we doing? I don't want to go to the next one until we got this one done. Yes? You subtracted the means for all the data entries, right? Now, one thing about distance though, can distance, wait, let's not get there yet. What did you just calculate? It starts with a D. It's not distance. What is it? The deviation. Good, thank you. So, what is the next column? Deviation. So basically it's that number you just calculated, okay? So we need to copy it over to the next column. And so everyone click on this cell. I just need the number to come over to the next column, okay? So press equals. And I want this column to be the result of this. So just click that, C5, and press enter. Okay? Again, equals, and then click the result, and it'll bring it to here. Now what do? Drag it down. Good. Drag the corner. Good. And it should be the exact same number, right? Okay. We're good? Okay. Alright, now, the next thing I was going to say. Can distance be negative? Can I tell Frank, you're negative 5 feet away from me? No, distance is positive. So, if the distance for the people that were, the wait time was early, we need to make it positive. So what is the next column? What does it say? Squared. When you square something, what does that mean? What does squared mean? By itself, how many times? Twice. So, do y'all remember the Pythagorean theorem formula? A squared plus b squared plus c squared, the triangle, the right triangle? There's a reason why we square distance, because distance can't be negative, okay? So, the distance for the deviations cannot be negative, so we're going to square them. Now, did y'all get a 0 here? Why is it 0? Click on it. Click the formula. What formula did I put in there for you? What does it say? The sum. So y'all remember when you add the left deviations and the right deviations, they should balance and equal what? 0. Okay? So, but let's do the squared. Ready? Alright. Everyone ready? Okay, equals. Click your deviation on the left side of it. Okay, and then to do squared, you need a caret top. Your caret top is Shift 6. Shift 6 is your caret top. And then squared means what number? 2. Okay, one more time. Equal sign, your deviation on the left, caret top 2, so it's squared. And then drag your formula down for the rest of the cells. Okay. So here's all the deviations squared. How are we doing? Good? All right, let's pause. What did we just calculate? What's deviation mean again? What's the deviation? Look at your definition if you need to. You just calculated deviations for company A, for the wait times. What's deviation mean?
How far a value is from the mean.
Good. How far the value is from the mean. So That is very important because we're gonna compare company A and company B tomorrow to see who's actually closer to their average wait times when I'm waiting for delivery. Okay? But how am I gonna find the average of all these deviations? Because there's so many, there's 20. How do we find average? If I want to know the average of your class's grade, what would I do? Add them all up and then good. So let's do that. Ready? Ready? Okay. Okay. Go under your squared deviations. Right under it. Let's start a formula equal. And what's the fancy word for adding in math? Sum. Good. Make sure you click sum, not sum if or some ifs, just sum. Okay? Everybody got that? Can y'all see? Okay, and I want to add everything from 26.5225 all the way down. Drag that blue rectangle, drag it all the way to the bottom. Press enter. Okay? So again, sum, and then drag your rectangle from 26.5225 all the way to the last one, and enter. Did we get the same number? Yes. Now, we added it. What do we need to divide by? 20. So right next to it, let's do another formula. Are you watching? Equals this number, 188.55, divided by how much? 20. Enter. Okay. Sum and then click the this one. This one. So equals, and then click that number, 188.55 divided by 20. And then press enter. Yes. Okay. All right. So this is the average deviation, correct? But we squared it. What's the opposite of squaring? What's the opposite of squared? Say again. Square root. So we need to find the square root of the average. So one last calculation and we're done, okay? Next to the 9.4275, everybody was able to get to that number? Okay, oops. Click next to it, another formula equals, and then start typing square root like SQR, and it should pop up for you. Make sure you don't click the one that says pi, click this one. Okay, you have to double click, okay? And then what do we want the square root of? 9.275. Good. So now you're going to type here, what is our standard deviation for company A? Let's round. 3 point what? 3.07. And remember, this is company A. Write that down so you don't forget this was company A. Okay? All right. Do you feel confident that you can do this tomorrow for company B? Yeah. Yes? No? Maybe? Okay, let's go back to our learning goal. Did you calculate the standard deviation of a data set with 100% accuracy? Yes, good job. Okay, subscribe. See you later.